Our research is focusing on tuberculosis control, and the major issue that we're looking at is how we can improve the control program by increasing the number of patients that are detected, that are essentially brought into a government control program. Our focus is on India, and in a state in India called Bihar, where Bihar has a very large prevalence of TB, but it has a very significant problem in finding the patients and bringing them into the government program. Outside of the government program, they typically find village doctors or private physicians that provide costly or inferior treatment that lead to poor outcomes. So what we're looking at is, can we design incentives that will be given to either the village doctors or community health workers, and through these incentives, they will choose to refer these patients to the government program. And the way that we're addressing this is there's an existing TB control program. It's a nonprofit organization that's working in Bihar and has essentially been created to bridge the private practitioners with the government program. And so they have experience and data and an ongoing control program. So we'll be using their data to develop a model of these incentivized networks and test their effectiveness in improving the case detection rate, which is the number of patients that are brought from the large pool into the government control program. Through the research, what we hope to do is deliver 4 different final outcomes. And what we'd like to have is, first, a good detailed understanding of how an existing program that uses these incentives works. So we'll know about the program costs, about how effective they are, about how well they can engage existing private healthcare practitioners, particularly these village doctors and community healthcare workers. So this data is one, I think, important source of data that will help create new policies regarding TB control. We also would like this model to have some impact in and of itself. So the model will be validated and tested using the field data, and we'd like this model to be able to be used as a decision tool to help policy evaluation. The model can be run for experiments, and we'll be using these experiments also to create policy recommendations for the national TB program. So we'd like this combination of grounded field data, a rigorous model, and then policy recommendations based on model experiments and the field program to give some very good insight in how you would improve TB case detection and eventually reduce the incidence of new cases. For NIHA's objectives, one of their primary 2 objectives that we're looking at is how we improve health outcomes by creating new policy addressing major health issues in Asia. And then another one is looking at how Singapore can gain prominence through their activities in this domain. So our project focuses very centrally on how we improve policy for very serious health concerns. Tuberculosis in the world is still a very serious concern. We have close to over 9 million cases each year globally, and around more than 1/3 of those are in India. And so this is a very large number of cases. And so our program, in terms of the impact it will have, addresses a very serious concern. And then also what we're going to be doing is, through the collaboration with NUS, the part of the team, this will actually increase this activity and increase the prominence of this type of work here in Singapore.